Okay, welcome back. This is section 4.5. We're going to talk about solving radical equations. We are going to solve a radical equation in one variable. We're also going to talk about how to justify algebraically why a solution is extraneous, as well as write and solve a simple radical equations to model a real-world context. Okay, so the first thing we're going to do is make sure that we isolate the radical on one side of the equation. Then we're going to raise each side of the equation to the power equal to the index of the radical, so that we eliminate the radical. We're going to solve the resulting polynomial equation. And then we're going to check our results for extraneous solutions. So what exactly is an extraneous solution? It is a solution that you get after you do all the algebra, but if you check it in the original equation, it makes the original equation false. So for example, let's say we wanted to solve the square root of x equals -1. Now, I know all of you know that that doesn't have a solution, but algebraically speaking, if we went ahead and squared both sides, so that is, I want to take the square root of x squared should equal -1 squared. And so when I do this, I say, well, then x must equal positive or -1. So if I check my work, if I check x equals -1, for example, I get the square root of -1 should equal -1, which we all know that's not true because the square root of -1 is I, and I does not equal -1. And if we try to put in x equals 1, we end up with the square root of 1 equals -1, which of course is also not true because 1 does not equal -1. So in general, we want to make sure that we are always checking our solutions by substituting them into the original equation. Okay, so for this example, step 1 is to get the radical all by itself. So that is, we want anything that's not inside the radical over on the other side. So we're going to add 4 to both sides. And so when we add 4 to both sides, we end up with the square root of 2x minus 5 on the left, and on the right we have 7. And so since the square root is all by itself, we can go ahead and square the square root to undo that. And what we do to the left, we need to do to the right. So now we have 2x minus 5 equals 49. And now we have a regular equation, so we can undo the addition and subtraction first. So we have 2x equals 54. And then if I divide both sides by 2, I get x equals 27. But we need to check to make sure that that is actually a solution. So we're going to check that x equals 27 by go ahead and put that in the original equation, which was 2 times x, which we're checking to see if x is actually 27. So we put that in for x, minus 5 minus 4 should equal 3. Now with the checks, we are only simplifying on one side. We are not doing any inverse operations. So 54 minus 5 is 49. You'll notice I'm not adding the 4. I'm leaving everything on the side that it started on. And so now that I get 3 equals 3, I know for certain that x equals 27. Okay, go ahead and try this one on your own. Welcome back. Here are the answers. Okay, so what happens if we have a radical on both sides? Well, we're going to do exactly the same strategy we did before. And we're going to start off by getting rid of one of the radicals. So we're going to try to put one of the radicals on one of the sides. And in fact, this is already done for us. So we're going to go ahead and square that. And so now we have x plus 6 equals, and on the right we have 5 minus the square root of x plus 1 squared, which means we're going to do 5 minus the square root of x plus 1 times 5 minus the square root of x plus 1. Okay, so we can go ahead and distribute here, right? So we have 5 times 5 is 25, and 5 times negative square root of x plus 1, and then minus 5 square root of x plus 1, and then negative square root of x plus 1 times negative square root of x plus 1 is positive square root of x plus 1 squared. And we still have the x plus 6 on the left-hand side. Okay, so let's go ahead and simplify this a little bit. So we have x plus 6, and then this here, negative 5 square roots of x plus 1 minus 5 more square roots of x plus 1, so it's going to be 25 minus 10 square roots of x plus 1, and then plus x plus 1, because the square root just goes away, because it's undone by the square. Okay, let's combine like terms. So now we have x plus 6 equals 26 plus x minus 10 square roots of x plus 1, and it's okay if you leave the x over here. Okay, so now we have another radical equation, so we're going to try to get this all by itself. So we're going to do that by undoing all of the operations. We want inverse operations. So we're going to subtract 26 on both sides, then we're going to subtract x on both sides, and so now we have x minus x is 0, 6 minus 26 is negative 20, and that's going to equal 0 and 0 and negative 10 square root of x plus 1. So now we can divide both sides by negative 10, and we end up with 2 equals the square root of x plus 1. Now that that radical is all by itself, we can go ahead and square that and square the left. And so now we have 4 equals x plus 1. And so if we subtract 1 from both sides, we end up with x equals 3. So now we just need to check that. Does x actually equal 3 when we put it back in the original equation? So the original equation said the square root of x, which we think is 3, plus 6 should equal 5 minus the square root of x, which we think is 3, plus 1. And so now we simplify, so we have the square root of 9 should equal 5 minus the square root of 4, and in fact 3 should equal 5 minus 2, which 3 does actually equal 3, which means that x equals 3 is a solution to this radical equation. Okay, go ahead and try one on your own. Welcome back, here's the answer. Okay, so what if the root isn't 2? Well, we're going to follow the same procedure. We want to get the radical or the fractional exponent piece all by itself. So what we want to get alone here is this 6q plus 1 to the 1/4. So I'm going to subtract 2 on both sides. And so when I subtract 2, I end up with 6q plus 1 to the 1/4 equals 3. And so now by my rules of exponents, if I raise both sides to the 4th power, 4 times 1/4 is going to be 1. So I'm raising 1/4 to the 4th power. So now I'm going to end up with 6q plus 1 to the 4/4, which is just 1, equals 3 to the 4th, which is 81. And so since this is just to the first power, really this is just 6q plus 1 equals 81. So if I subtract 1 on both sides, I get 6q equals 80. And if I divide by 6, I get q equals 80 over 6, which is reduces to 40 over 3, but doesn't reduce further, which means I'm going to have to check with a fraction, but that's not a problem. So I'm going to go ahead and check and see, does q actually equal 40 over 3? So I write out the original problem, which was 6 times q, which we think is 40 over 3, plus 1, all raised to the 1/4, plus 2 equals 5. Okay, so let's combine. So 6 technically is over 1, right? And So since these are being multiplied right here, we can divide by 3. So this becomes 1 and this becomes 2. So now we have 80 plus 1 to the 1/4 plus 2 equals 5. So 81 to the 1/4 plus 2 equals 5. And we know 81 can be rewritten as 3 to the 4th to the 1/4 plus 2 equals 5. So when we raise exponents to another exponent, 4 times 1/4 is just 1. So now I have 3 plus 2 equals 5, and 5 equals 5. So since that checks out, we know that Q equals 40 over 3. Okay, go ahead and try one on your own. Welcome back. Here's your answer. And let's try another problem. Okay, so let's try this one. Same thing. We want to get the radical by itself. So we're going to go ahead and start off by subtracting 4. And so now we have the square root of 2x minus 5 equals x minus 4. And so to eliminate the radical, just like we did before, we are going to go ahead and square both sides. And so when we do that, we end up with 2x minus 5. And we notice that that's a binomial. So we're really doing x minus 4 times x minus 4, which is x squared minus 8x plus 16. And if you don't believe me, you're doing x minus 4 times x minus 4. So you can go ahead and FOIL that out, and you'll see that that works. Okay, so now it looks like a quadratic problem that we had back in Unit 2. So let's go ahead and subtract 2x from both sides. And I'll add 5 to both sides. And on my next line now I have 0, because this is 0 and that's 0, equals x squared minus 10x plus 21. And so now I'm looking for the multiples of 21 that add to negative 10. So what multiplies to 21? Because remember A, that's 1, C, but adds to negative 10, and so negative 3 and negative 7 most certainly work out. So let's go ahead and factor this quadratic to x minus 3 times x minus 7. And by the zero product property then, x minus 3 equals 0 and x minus 7 equals 0. So that means that x can either be 3 or x can be 7. So let's go ahead and check and see if that works. So in order to check, we're going to put 3 in first. So we have the square root of 2 times 3 minus 5 plus 4 should equal x, which is 3. So we're just substituting in 3 for x. So anytime we see x, we put in 3. Okay, so now we have 6 minus 5. So 6 minus 5 plus 4 should equal 3. Well, that's going to be just 1. So 1 plus 4, but that doesn't equal 3. So 5 does not equal 3. So that means that x equals 3 is not going to work out for us. Okay, so let's go ahead and check 7. Sorry, that's over top that. So we're going to do the square root of 2 times, and we're checking 7 here, right? 7. Minus 5, and then out of the square root plus 4 should equal, and we're checking x equals 7, so should equal 7. Okay, so now we have 14 minus 5 plus 4 equals 7, which of course is the square root of 9 plus 4 equals 7, which of course 3 plus 4 does actually equal 7. So since 7 equals 7, we know that works. And so we can say that x equals 3 is an extraneous solution because x equals 7 is the only one that makes the original equation true. Okay, go ahead and try this on your own. Welcome back. Here's the answer. Okay, so this works for even higher powers. So again, we want to get the radical all by itself. So we have 4. We're going to go ahead and add 12 to both sides. So now we have 4 times the 4th root of 3x plus 6 equals 12. So we go ahead and divide everything by 4. So now we have the 4th root of 3x plus 6 equals 3. And we can go ahead and raise everything to the 4th power because we know they're equal. And so now we have 3x plus 6 equals 81. And so we subtract 6 on both sides. And we get that 3x equals 75. And when we divide by 3, we get x equals 25. So we need to make sure that we check, does x actually equal 25? And so we write the original equation, 4 times the 4th root of 3 times what we think is x is 25, plus 6 in the radical, all minus 12 should equal 0. So we go ahead and simplify. Remember, we are going straight down. So we're not doing any inverse operations. Everything's going to be equal. We're not moving anything over. So 4 times the 4th root of 3 times 25 is 75 plus 6, all minus 12 should still equal 0. So 4 times the 4th root of 81 minus 12 should equal 0. And so 4 times 3 minus 12 should equal 0. And of course, 12 minus 12 does actually equal 0. Since 0 equals 0, we know that x equals 25 is a solution. Okay, go ahead and try this on your own. Welcome back. Here's the answer. Okay, so I'll give you a moment to read this. Okay, welcome back. So we know that we're on a boat, right? And so part of this is talking about our distance from our eye level to sea level. And so then we have this formula here. So we know that d of h, right? Because this is the distance in nautical miles. So d of h is, and is means equals, so equals 1.17 times the square root. So we need the square root of the height. So this is h here, right? Okay, so if we know that we are 10.5 feet above the water, so that means h here is 10.5 feet. So we can just plug that into h, right? So h becomes 10.5. So now we want to know d of 10.5. And so that should be equal to 1.17 times the square root of 10.5. And so I can put that all directly in my calculator. And when I do that, I notice that d of 10.5 is approximately equal to, because we have to round, 3.79 nautical miles. Now, nautical miles are slightly larger than regular miles, and you can read a little bit about that below. Okay, here's a super awesome U-Try to check out your algebra skills, so go ahead and try it. Okay, welcome back. Here's the answer. Okay, so thank you so much for listening. If you want some more examples, go ahead and watch some more examples video. Otherwise, go ahead and complete the 4-5 solving radical equations reflection. And up next is the next unit. We're going to talk about sequences and series.